basically Northern California. We conduct either a webinar or on-site meeting every month on information management topics. On-site meetings are arranged in member companies in somewhere in the San Francisco Bay Area. So for this month's webinar, we are very delighted that Couchbase decided to co-sponsor the webinar on the navigating the transition from relational to NoSQL technology. We have been wanting to have this topic covered by Deepthi Bodkar since last year. So we're extremely happy about this. At the end of the, after the seminar is over, we'll post the presentation SFDAMA.org website. If you are not a member, please visit SFDAMA.org website, and there is you can easily become a member by going through filling up some forms. If you have any question, don't hesitate to contact me through an email. My email is also listed in the website. So Deepthi, I'm going to give it to you. Thank you very much.
All right, thanks, Mani. Welcome everyone to our webinar, and without much ado, let me actually just start with the content. At the high level, I'd like to walk through a couple of different areas. First, we'll look at why people are moving to NoSQL or looking at NoSQL technologies. We'll then step through some of the key differences between relational technology as well as NoSQL technology, and particularly focus on the data modeling aspect as well as scalability. And then we look at what are some of the use cases and what are considerations that you need to keep in mind as you're walking through this transition. If time permits, I'll go over a quick overview of Couchbase Server and some of the details on that. In general, there have been significant changes from the time the relational databases have been around. If we just walk through this table really quick, in the 1970s, there were very few users for applications. Today, you probably start off with just basic testing with about 2,000 users, and you might have no endpoint because your applications might go viral. You might have to support millions of users as a part of your web application. The population as well is dynamic. You have less control today over how many users are using the system, how many move away from the system. The churn is a lot more, and so your data management tier needs to be dynamic as well. From an applications perspective, there are a lot of different innovations that have come about. Before, the focus was about automation. A lot of it was walking through converting a manual process to an automated process. But now it's a lot more than that. Technology is a part of our life, and applications and apps are an inherent part of those. And whether it's shopping or social networking, there are all kinds of applications which have very different requirements from the data management tier. Particularly in terms of the structure of data, we've seen that the kind of information that needs to be represented in the database has significantly changed over time. From the rows and columns that used to be the case for certain applications, you now have the need for semi-structured data or completely unstructured data, and the data management tier needs to keep up with these requirements. And most importantly, the infrastructure has completely changed, and there's particularly a few trends, cloud computing being one of them, and just having the cost of memory and the cost of networking having significantly reduced. The infrastructure requirements have changed quite a bit, and technology that was built for a different infrastructure may not necessarily work well today on the newer distributed infrastructure. So at a high level, we understand why this trend is happening towards NoSQL, but we actually performed a survey sometime last year, and we had about 1,300 responses to this. And there were two things that came up. One was inability to scale, which was something that we were aware of because we've been looking at the space. But more importantly, what surprised us was the number one reason that people were looking to move to NoSQL was the lack of flexibility, the rigidity in the schemas. the expensive alter table operations, which in some cases might take a couple of weeks to a month to implement across the stack. And so this was a key reason why people are looking to move to NoSQL. Just a quick catalog of some of the NoSQL databases out there. While this is not comprehensive in any way, what I do want to highlight is there are various different kinds of NoSQL databases. We think that Memcached was one of the first NoSQL databases, even though it's a cache-only solution, but it's a key-value cache, and it does provide sub-users with NoSQL characteristics. Membase, which is where Couchbase originates from, is a database which is a key-value store with persistence. And then you have other structure, Redis, which is a more data structure oriented. Document databases are becoming incredibly popular. Couchbase is a document database. You also have MongoDB, which is another popular database. CouchDB is a single server document database, and Couchbase inherently takes the attributes of Membase and CouchDB and builds a very a true distributed document database that can handle caching, that can handle low latency requirements, high throughput requirements, as well as the flexibility aspect. Columnar databases like Cassandra are more typically oriented towards analytic workloads, and then you also have graph databases like Neo4j, which are more oriented towards graph analysis, path analysis, more for the semantic side of things, so the semantic work. Let me just do a quick check of. Let me just do a quick check on questions. We'll get to there was a question about APIs, Couchbase APIs, and we'll get to those towards the later part of the presentation. So, are you being impacted? Fast enough stream? Are you just using your NoSQL, your relational database as a key value store? Are you purely just storing keys and values and trying to shard it yourself in the application tier? Both these point to some inherent problems of relational databases, and we'll take a look at those. In terms of scalability, the relational model is really a scale-up model, and so what we've seen is a lot of people tend to keep upgrading their system. And some of the heavyweight code for simple applications, right throughputs do not keep up with expectations, particularly for web applications. And this is an area where you might see the biggest need for NoSQL. You might have SLA requirements for latency, which directly translates to better user experience, and that might be another reason. In general, if your user base and your data is growing at a tremendous pace and your relational database is not able to keep up for these applications, NoSQL provides a very good choice. But before we get into the differences, I want to spend some time talking about document databases in general, distributed document databases, what a document database is, what are the concepts, and how you can use them. Inherently, each record is stored as a self-describing document. You see an example here. You have attributes like time, server, type, and so on. And each document has its own structure, and so each document can look very different, can have different attributes, and all these can be stored in a single bucket or in a single database. Documents can be fairly complex, that is, they can represent hierarchical structures. And so here you see in the details field that you can have tags, the tags attribute that's actually an array. You can have the details attribute that's an object within itself that is embedded within the JSON on the top. And so you can have fairly complex representations for data. In general, you have a unique key similar to a primary key, and this is what's used to access the document directly from the database. Typically, there are a variety of different formats that these documents are stored in. JSON is becoming incredibly popular, and that's something that Couchbase uses to represent this information. XML is another alternative, and some other databases use derivatives of JSON or XML. MongoDB, for example, uses JSON, which is binary JSON. In terms of the content itself, document databases build onto key value stores. And so in a key value store, you basically have a very limited access in terms of getting the document using the unique key that belongs to it. But with document databases, now you can actually look within the content and get access to the attributes, create indexes on these attributes, and query them, and so on. In addition to this, these databases offer sharding mechanisms. In some cases, they are hash partitioned, which is uniformly distributed across the entire cluster without any hotspots, because it's a random distribution. In some cases, you have more range partitioning like sharding, which might lead to some hotspots. But in general, there are sharding mechanisms that automatically take care of this data distribution for you across the cluster. In addition to that, high availability is one of the key aspects, and so most databases support replication mechanisms. In some cases, they are master-master. In some cases, they are master-slave, and you can fail over to the replica in case of failure. So before jumping into data models, let me do a quick check on the questions. None yet, but hopefully they'll come in a little bit. So I'm sure some of you have seen a schema that looks like this. Plenty of tables, lots of joins across foreign key constraints. This might be an application that you're working with today. However, some of these applications might require a very deep transactionality across multiple records, and NoSQL technology is in the early stages. And so while today you may not be able to migrate such a complex application over time, we hope that to add more features and make the NoSQL technology a robust option for these. However, there are plenty of applications today that use NoSQL technology, and these are some of the use cases that we'll take a look at. In general, relational databases follow a row and a column approach, where you have it's extremely structured. Every row has the same columns that belong to it. You have and you typically have a primary key that can be used to point to a specific record. On the other hand, with the document model, every record looks very, very different. It can have a very different structure, and it can have a nesting, and it can be hierarchical as well. So let's take a quick example of an error logging use case, and then we'll see how this can be represented using the document model. So here you have two tables. You have the error log table and a data center table. The error log table is essentially capturing all the errors that might be that are being generated, perhaps the error message, the time associated with it, and then a foreign key pointer to the data center where it actually occurred. and you have several such records in the error log table. Typically, when you want to construct the full record, you will perform a join across the two tables and match over the foreign key. In this case, in the data centers table, you have a location of where the data center exists, as well as maybe a phone number and maybe some additional information about the data center. But how would you represent this as documents? And so a document is essentially a pre-computed join is a good way to think of it, where each record includes all the information about a specific entity. So in this case, we've now converted we still have the ID and the error name. We have the time, but we also have the data center attributes in here, and each record in the error log table is essentially an individual document. So now when we look at schema changes, it becomes extremely easy to update the schema on a real-time basis. And so as maybe you start receiving, you plan for some additional attributes to be added to the document. These can be added anywhere within the document. In this example, we have a component and a severity level, perhaps. And the schema change makes it incredibly easy to change your app, to have new data come in, which may have a different schema without really changing the application. Of course, you might have to change the application to use this information, but there are no complex alter table operations that need to be performed, and so you can iterate faster over your application development. In terms of document modeling, there are a couple of different approaches. As you've seen, while it is a document can be represented as a pre-computed join, if some of the information is redundant, then you will be repeating it multiple times. And so we'll take a look at some of those use cases and how to represent them. But one thing to think about is, as you're modeling your documents, are these completely separate objects in your models here? Are these objects accessed together, or are they typically just accessed completely separately? And do the updates on these objects need to be atomic? Do they need to be updated at the extremely same time, like in a traditional database? And another aspect to look at is how many people are concurrently updating these documents. Some of these aspects are important because with NoSQL databases, while they have a lot of advantages, there are no concepts of join yet in the database. And so you need to take care of this in the document modeling layer itself. So think of a document as a logical container of your data, and then group them based on access patterns, editing patterns, and object entities. Inherently, there's two approaches. One is, as we've looked at earlier, just have a very simple approach. You have one document that contains all the related information. It's denormalized, and it does give much better performance because you have direct key value access to this data. It scales better because you can very, very easily distribute this data across more servers if the throughput needs increase. And it eliminates any complex client-side joins, because otherwise you'd have to access the two documents and perform the joins perhaps in the application tier. On the other hand, if you have very different objects that are not accessed at the same time, have different editing patterns, then they need to be represented as different document types. And this obviously improves it reduces duplication. So your data is not now duplicated across multiple documents. However, given that we auto-shard this data, the objects may not be co-located, and so while from a latency perspective, it may not be a problem because you can access the data across any node in the cluster. Given that they're not co-located, while expanding the cluster, there might be a problem with them not being co-located or not being moved together at the same time. Transactions are not supported for multiple documents. We are consistent. Couchbase, for example, is strongly consistent at a document level, However, there are no NoSQL document databases that support multi-document transactions. And then joins are also not supported, and so this might be something that you need to take care of in your application here. Let's take a look at the document IDs. Similar to relational databases, you have a primary key in a RDBMS. You have a document ID or a key in a document database that's heavily used to access your document individually. And lookups using the ID are incredibly fast. With Couchbase, with some of our benchmarks, we've seen microsecond response times. And so this is the main reason for one of the key reasons for using NoSQL technology, because of the low latency. In general, you have these IDs are unique, and so they appear once in a bucket. A bucket is something that we use. It's synonymous with a database. In some cases, you might have a collection or a table. You need to start thinking about how do you actually use these document IDs, because they can be very effectively used to understand and model your data as well. So most basic use cases, you can use a unique identifier, or you can actually have date-based IDs, perhaps for each the month of the year. You start off a sequence, which then gets advanced for each blog post that might be coming in for that month, or you could use numeric IDs. But you can also use handcrafted IDs, and these become very effective, particularly once you have access to views and querying to logically model the data. And so you can have an ID which has a category at the front, followed by the name or an email address, so that you can uniquely identify them. You can also use matching prefixes for related objects. It is a good way to model your keys so that you can reference these objects very easily. A couple of questions. So let's take some questions and then move on to the blog example. Is NoSQL ACID compliant? Now, in general, each database is very different. In some cases, like Cassandra, you have eventual consistency. With Couchbase, we are extremely strongly consistent at a document level, and so every read and write for a unique key or a document goes to only one location, and so it's strongly consistent at a document level. For multiple documents, if you have an update that is touching multiple documents, then that is not an atomic operation. But along the way, as we mature the product, we will eventually add some of those aspects. Are joins possible with NoSQL? At the moment, most NoSQL databases do not support joins. This is because joins are while they're important and extensively used for relational databases, typically document databases, a lot of different objects are stored in the same database, and so the access to this data is based on the keys or using queries. At the moment, self joins or cross collection, cross database joins are not supported by most databases, by most NoSQL databases. Next question. Why would you say that document databases are more evolved than key value databases if your application is more data centric? That is, when your business logic is complex and data driven. The main reason that document databases are more evolved than key value databases is because you can actually do something more with the data, with that document, that you may not be able to do with your key value store. In a key value store, you might store JSON or blobs, access them using the IDs. However, while you can have complex code in the application tier to see what's inside the actual document, it could be you want to look up a name, you want to make a key lookup by a name and an email address. that is not the key. And so in order to do some of these additional lookups and in order to get sorted outputs for maybe a player's points, you need access to querying, and that access is available in document database. How is the presence or the absence of a key checked in code? Does this lead to loading the application? In general, key access is you use set and get operations in Couchbase as an example to access the key. And in terms of presence or absence of a key, in a key value store, you know for sure whether the key exists or not. And so if you look up a key that doesn't exist, you will get an error message back. Some of our more detailed technical presentations cover some of this material, so it might be helpful to you to look at some of our older webinars. Can you show us an example for separate documents for different document objects and how to cross-reference them? Great question. This kind of leads me to the example, and so let's move back to the presentation and take a look at the blogging example. So here we have a couple of different objects. We have a user profile, we have a blog post, and we have blog comments. Typical for a blog application or even a content application, any kind of a content application. In option 1, we talked about a single document representing all the information for a specific blog post in one document. And so here you see that you have IDs, you have the author, you have the type, which is in this case is the post. It could be also the user profile, for example, which would be another document type. And then you have other information here that's relevant to the blog. What I'd like to point out is that it also includes the comments as an array, where the actual comment text is part of this document. So you might have maybe a few different comments in here. In this example, we see 2 comments. But in some cases, maybe you have a very popular blog post that has hundreds of comments. And so in that case, it's easier to represent it, and it might be more efficient to represent it as 2 different documents. And so here we split out the 2 objects into a blog document, which is the main document that then accesses the other type of object, in this case, a comment. The comment document now contains the actual text for each comment. And so if you have 5 different comments, you will have 5 different documents. In addition to this, in your blog document, your ID actually points to the ID of the comment. And so in your application, now when you are representing this blog, you can very easily access through this array the list of IDs, and then for each ID, go and grab the content, the comment that it points to. And so this way you can kind of simulate a join using this approach and perform this in the application too. Now, extending this even further, you can have several different depths of linkages. So you might have a blog, then has a list that only points to the first comment, perhaps, and the first comment might be incredibly popular, and so people reply back to that comment directly, while you have other lists for the other documents to represent more comments. So you can walk through this and very effectively build your application simulating these joins, but at the same time getting very, very low latencies on these accesses. So one thing to remember, as someone asked earlier, is are joins supported by the database? And the answer is no. At the moment, no NoSQL database supports joins. And so some of this logic you might have to build into your application. Depending on the data model of your application, if it's very simple, then using a single document approach would make sense. If it's starting to get a little more complicated with different kind of objects that need to be embedded, it would be better to use a linked model where you have multiple objects that and access them, use multiple document access APIs to access these documents. All right, so the next step is comparing scaling models. So we've looked at So far, what a document database is, what the key concepts are, how the modeling differs from a relational database. But another aspect, and this is the second reason why a lot of people are looking at NoSQL, is the scaling model. And so let's take a look at the scaling model. In general, with relational databases, and with an application that uses relational databases, this is the typical stack that you might see. So you have web browsers on the front end. You might have a load balancer that is balancing load across multiple web servers, which are pretty stateless. And so as the demand for your application increases, you essentially just add more web servers onto the site. However, in terms of the relational database, typically it's a scale-up model, and so you might end up buying beefier machines, but up to a point, because at some point your costs are going to start going exponential, as well as your performance. More importantly, your performance in terms of latency and throughput will start to get impacted, and you will need to look for alternative choices. While you could try to shard the data yourself, there are a lot of different problems that arise because of that. In general, with NoSQL databases, the database tier now horizontally scales, and so as you have as your number of users increase, you might add more web servers. Now you just simply add more database servers, and then the data is distributed across those servers. You get linear scalability across cost as well as performance. We'll take a look at some of the auto-sharding concepts in a little bit, but there are some of the other considerations that you need to think about while making this switch or while choosing a NoSQL database. So let's walk through some of them. So the first one is accessing data. When accessing data, there's one thing to think about is, well, what are the languages that you need, that your developers are coding in, and do these databases have a client, have APIs specific to those languages, because that makes the development process extremely easy. And so check if the SDKs exist. For Couchbase, we support most of the popular languages. Java and .NET tend to be the most popular ones amongst the ones we have. For some kind of web applications, Ruby and PHP are popular as well, and those may be some the ones that you use. In terms of the HTTP API, what we have noticed is that from a performance perspective, if you are aiming to achieve thousands or hundreds of thousands or millions of transactions per second, then the best approach to interfacing with the database is using a native API. And while HTTP APIs are extremely helpful for management, monitoring, as well as maybe for smaller applications, because of the simplicity, it does not have those performance characteristics that we have seen with our smart clients that automatically take care of topology changes and so on. Next one is consistency, and we've talked a little bit about consistency. There was a question about it as well, but inherently we are consistent at a document level. This is Couchbase. MongoDB also mentions that they are consistent at a document level. However, some of the other databases are eventually consistent, and so you might have to the read may not immediately see the update from the write. In the case of Couchbase, you can have you have different ways of applying consistency. So we have optimistic concurrency as well as pessimistic approaches. Pessimistic approaches include actually getting a lock on a specific document when you are accessing it, and the optimistic concurrency approaches include a check and set mechanism where you get a document. You look at a unique identifier, which we call a CAS, and then you set using that CAS. If it matches, you know that there have been no updates that have happened between you getting the document and setting it back. If the CAS doesn't match, then you know that there has been an update, and you can and the application can take care of it. And so analyze your application needs. If you need to have a strongly consistent database at a document level, then Couchbase might be a good solution for you. In terms of availability, there are different approaches. With Couchbase, we have an approach where every node is identical. So every single node includes some active and some replica data, and the replica information is transferred to a configurable number of replicas. It's a master-master approach. But for MongoDB, you have a master-slave approach where you have one node is a replica and a different node is the active node, and so this creates might have more complexity associated with scaling out, because you have different nodes that are active, different nodes that are replicas in your cluster. Operations is a very important aspect, particularly for enterprise customers, and this is something that we work very hard to differentiate ourselves with. Monitoring system, we have a great UI where you can take a look at all kinds of metrics, ops per second, all the details on the shards, the replication information. We have make sure you have backup and restore. It's obviously important for disaster recovery, and upgrades and maintenance. This is an area where we've got a lot of feedback from customers and users about applications being online 24/7, and there is no ability to take a downtime at all. And so we actually have online database upgrades as well. You can upgrade a cluster by rolling in a few nodes at a time with a newer version of the database. And so you can have a mixed cluster where you have some nodes that are on an older version, some nodes in a newer version, and your application does not get impacted at all because because the app is always online. Scaling is, we've talked about it a little bit, but there's two approaches, and what Couchbase picks is consistent hashing, where the client takes care of the topology changes and handles it completely for you. So the application is not aware of where the data lives, or even which servers that are serving the data. The client takes care of it for you using the consistent hash as well as the shards. And then finally, indexing and querying. This presentation doesn't go into all the details, but essentially you want to be able to create secondary indexes as well as aggregates, find aggregates, groups, and we use incremental MapReduce approach in Couchbase. At the moment, we don't have support for ad hoc querying, and that's something that if you have a smaller application where that might be more important, MongoDB might be does support it. So is NoSQL the right choice for you? Is it something that you need to look at right away for your applications, existing applications, or maybe for that new project you're thinking about? In general, it is great technology that's extremely suitable for specific use cases, and we'll take a look at some of those use cases. But if your application needs multi-document transactions, if you have complex security needs from authentication or even document-level security basis, if you have complex join requirements across buckets, across collections, then NoSQL may not be the right choice for you at the moment. As the technology matures over the next few years, we will add these features. But at the moment, what it's going to give you most value for is the low latency, the high performance, and the scalability aspects, as well as the extreme flexibility. Before jumping to the use cases and where it's a good fit, let's take a look at some of the questions. How is NoSQL similar or different from OLAP designs in relational databases? So typically, NoSQL databases are a better fit for the OLTP side of things, right? All the stuff that I've talked about so far might point you to the OLTP side of things, where you have extreme latency requirements, throughput requirements. On the OLAP side, we do have some users trying to use incremental MapReduce for real-time analytics. While it is not as extensive as OLAP, the traditional OLAP approaches, it does give you a more visibility and insight into your data on a real-time basis. And so, for example, with Couchbase views, you can create leaderboards, and you can see which tags are most popular amongst your data, or you might want to see who has been posting the most number of blogs. And so, in some of those to answer some of those simple questions, NoSQL does provide a good choice. If you have very complex OLAP requirements, then you might want to pick a more traditional approach. The other approach that our customers do use is Hadoop on the side, where we do have a Hadoop connector that particularly for ad targeting kind of use cases, you might have long-running jobs that find matching interests, and then once you have that information, push it back into Couchbase and actually serve it up. And so at the moment, most of the use cases are more on the real-time web application side with some simple real-time analytics. A question about the document itself. After we add more attributes to the document, can we update the old document to set the values to new attributes? Yes, you can. It is an extremely flexible schema. And so you can add attributes, as many attributes to the document as you need on the fly. And you can update the values just as you did with a relational database. You can change these values and go back and set the document back. But these updates happen at a document level. Main reason being that we keep it atomic. In Couchbase, in version 2.0, we will use an append-only tree, and so essentially the write overhead is very little on disk, because we don't use in-place updates. We have append only at the end. What is the difference between Couchbase and CouchDB? Great question. I have a slide on that actually, and so let's wait a little bit towards the end of the presentation. In Couchbase, is there a concept of a primary master? How simultaneous reads and writes are being differentiated at the node level? So in Couchbase, let me actually just bring up a diagram here. Every node looks exactly identical, and that's the high-level architecture. And so every node has a data manager and a cluster manager. The data is managed by the data manager, and the cluster manager takes care of the cluster-wide operations as well as monitoring stats and the UI. In general, you have an architecture that looks like this, where you have a Couchbase client library that understands the topology. The topology is shared by the cluster manager to the Couchbase client library. And so the client library knows exactly where a document lives, which node it lives on. And so it directly connects to that node, accesses the document. And so for every document, it will only live in one place at the same time. So this is the active data. We obviously have replicas which might live on other nodes. Those replicas are used for failover cases. For read and write, all those accesses go only to the active virtual bucket, as we call them, to the active shard. And this is because we don't have any problems with throughput. And so we have, you can perform hundreds of thousands of operations per second, even with a very small cluster. And so the replicas are mostly used for durability and failover reasons. Is MapReduce in Couchbase different than Hadoop? It is different from Hadoop. It is incremental MapReduce, which is a specific kind of MapReduce that is extremely effective for real-time cases. And so our indexes are built using this approach where only the changes that arise from the updates of documents get processed along the way. And so it is an incremental process. We don't have to go over the entire data set multiple times. This is extremely effective, particularly in real-time applications. What it prevents you from doing, or it restricts you, is performing long-running jobs with multiple chains of map and reduce. So for those kind of processes and jobs, it's probably best to use another system like Hadoop, which is really meant for the large-scale batch processing of jobs of data. So let's go back to some of the use cases, and if time permits, I'll quickly go over the high-level architecture for Couchbase. In terms of use cases, there's two kinds of use cases. There's a performance-oriented use case, and there's a data-driven use case. For performance-oriented ones, as I've mentioned already, we have where you have low latency requirements and high throughput requirements, like session stores, using a NoSQL database as a caching tier for user profile information, for social gaming and ad targeting. So there's a lot of different use cases where these are the key requirements that the application needs, and Couchbase and some other NoSQL solutions are very good fits for these applications. In addition to that, if your data access is predominantly document-based, so for example, if you have a very customer-oriented application where you track information on a per customer basis, then it might be a good solution for your problem. Workloads with high mutation rates, and so if you have a high throughput, a high write throughput, we do very well with write throughput, because we have a very low granularity of logs, unlike some of the other databases which might have a database level write log, which prevents you from performing a very write heavy workload. The data-driven use cases, we have a lot of these where data is changing constantly. You might have unlimited data growth. You might have more hierarchical data that you need to represent. One interesting use case that's coming up more and more is third-party defined data. And so you don't have control over the data. You are using a data service, whether it's could be Twitter, or could be a healthcare service that's providing data. You have less control over that data, and you just which might change structure, and you might want to use a database that is schemaless, and NoSQL becomes a very good choice here as well. So with that, we have a few minutes left. I'd like to give a quick overview of Couchbase and talk about, try to answer some of the specific questions that were asked earlier. Couchbase is a NoSQL document-oriented database. There's a lot of different functionality that we have. In general, our users use us for our consistent high performance and easy scalability, along with being able to be always online with whether it's upgrades, software upgrades, hardware upgrades, and so on. Long list of customers. I'm not really going to spend time on this, but we do have a lot of enterprise customers in production. I talked about the architecture a little bit, so let's go into some more details of how it actually works. With Couchbase, when you set a key, and the set is essentially equivalent to an insert in a relational world, it comes into the node that is responsible for that key, and this is only showing the active data. Once it comes in, you get a response immediately saying that yes, it has been written, and it immediately also gets promoted to the replicas. Where in this case you have two replicas, so you get pushed out directly from memory into those replicas, and so it's incredibly fast. and it also gets pushed down to the persistence tier for being written on disk. Given that it is a RAM-based access, this access is incredibly fast. And so if for your working set for your application, which is maybe the active list of users, you will see a sub-millisecond response time. In terms of the basic functionality, here we see a cluster with 3 nodes with active documents. We also have the replica documents for different nodes that are spread across. And so here you see that document 9 is now also available on server 3, but that's the replica. On the application side, you'll have the app server, and that's typically where the Couchbase client lives as well. You have a cluster map that the Couchbase client takes care of for you, and this includes the cluster topology. And so when a request comes in for a specific node, for a specific document, say document 5, whether it's a read, write, or an update, the client library knows exactly where that document lives based on the cluster map, and goes and accesses that data. When nodes are added to the server, to the cluster, you can add multiple nodes at a time, and this entire process is an online process, and so the data distribution happens while the application is up and running. You add 2 nodes, and you perform a rebalance operation, which is a single click of a button on our UI, and the data gets distributed uniformly across those nodes. What happens is then the cluster map gets updated, and now the client knows that document 6, for example, doesn't live on server 1 anymore. It actually lives on server 5, and it can go and directly access that document. In case of failover, we do have replicas, and so if a node does go down while it's accessing information, immediately what happens is that we have auto failover and manual failover, and so the replicas get promoted to active, the cluster map gets updated, and the clients start pointing to the relevant servers that have the content. Simple ways of reading and writing data. It is RAM-based access, and so it's extremely fast. It also, the replication happens from in memory. And in general, we have fairly complex engines that take care of replication queues, disk write queues, and you have access to all this information from our UI. With that, there's a couple of questions that I do need to answer, but let me jump to one last slide, which is the difference between CouchDB and Couchbase. CouchDB is a single server document database, so it is not distributed. It also has a very different API and a very different access pattern for data. It is JSON oriented. It is both are open source, but inherently there are a few key differences. With Couchbase, you get the auto sharding and the cluster technology. You have online rebalancing, online upgrades. The SDK access is the best way to access the cluster and the data for high performance needs. It is completely Memcached compatible, and so if you have existing Memcached applications, it's an effortless migration process. And it also has a built-in cache, and so for high performance needs, it is a much better solution. Let me take a quick look again at any additional questions that may have come in, and wrap up the webinar at the top of the hour. Are there data modeler? Is there a need for a data modeler or a DBA with a NoSQL solution? Looks like the app developers can do all the work. It is a database at the end of the day, and on the operational side, while it is incredibly easy to maintain, to scale, you do need some monitoring. You do need someone to oversee operations, and also to keep a watch on data patterns. How many buckets do you need? How are the accesses to these buckets going in terms of latency, in terms of cache misses? And we actually have a separate presentation on Couchbase in production that will give you a little more insight into the operational and the database needs of the for NoSQL solutions. All right, and the last one seems to be very excited after this webinar. Thanks, Dipti. And so with that, I'd like to end today's webinar. Thank you very much for joining us today. That's my email address. Please feel free to reach out to me. I'm available for questions if there's something that wasn't clear. And we look forward to you joining our future webinars. Thank you very much.